Systems of equations, systems, word problems, part 2. Here's our problem. Una bought 14 flowers for her mom on Mother's Day. She bought pansies and gladiolas. If the pansies cost 75 cents and the gladiolas cost $1, and she spent $11 total, how many of each flower did she buy? So this, I kind of wrote this a little weird. It should say it cost 75 cents each, right? $1 each. Now, what's different about this than the types of systems, equations, word problems that we did last time? The main thing is that what they're asking us is how many. So I'm going to have two variables here. The P for pansies and the G for gladiolas. But instead of having the variables be the cost, like we did last time, so if I said like 2 erasers and 3 pencils cost $5, you would say E is the cost of an eraser and P is the cost of a pencil. In this case, we're looking just for how many gladiolas and how many pens. So I would start by writing out P and just what that is. The number of pansies, and then G, the number of gladiolas. And I didn't tell you to do this before, but it is always kind of smart with the systems of equations word problems to start by writing out your variables. Now we're going to look at this huge paragraph. We're going to try to figure out what types of equations could we write. She bought 14 flowers. What does that mean if she bought 14 flowers? That's the total. So what would equal 14 then in that case?
7%.
We're going to use our variables to say something is going to, the total is going to be 14. Yeah. So P, we don't even really have to say the X. We're going to say P because that is a variable. Exactly. The number of pansies, that's P, plus the number of gladiolas, that's G, equals 14. So the total number of flowers is 14. Now we have all this information down here. And it's not always all going to be together like this. Or something like that. Pansies cost 75 cents. Gladiolas cost $1. She spent $11. And this is the new part. This is the part that's kind of a trick. So when I see pansies cost 75 cents, the way that I can write that into my equation is I can say 75 times P. 75P plus the gladiolas cost $1. I want to write $1 in cents. So $1 is 100 cents. 100 G. And that's going to equal the total cost. If we take the cost of a pansy times the number of pansies, we get the amount that she spent on pansies. And if we take the cost of a gladiola, 100 cents, times the number of gladiolas, which is G, we get the amount that she spent on gladiolas. So this is how much she spent on pansies. And this is how much she spent on gladiolas. And so the other side is going to equal the total amount that she spent, which we know is $11, or 1,100 cents. That's the total that she spent. I don't know how well that's showing up on can see it. I'm going to switch back to black. I think it's a little bit clearer. So we now have two equations. I'm going to go over them in black. P plus G equals 14. And our second equation, 75P plus 100G equals 1,100. And from those two equations, we can now find our variables. We can now solve this word problem. So, there's a couple ways we could do this. I think probably the easiest way, the way that I see, is I'm going to multiply this top equation by 100. So that's going to apply to this, and to this. And then I'm going to multiply the entire bottom equation by -1. And you'll see why I'm choosing this one by -1 in a second. So the top equation times 100 gives me 100p plus 100g equals 1400. And the bottom one, I'm going to get -75p minus 100g equals -1,100. Now the key thing that I have here is I have 100g minus 100g after I've multiplied. So when I add these two equations together, that will drop out. Boom. And the reason that I chose to make the bottom equation negative is so that I would have a positive answer. 100 minus 75 is going to give me 25p equals, and then 1,400 minus 1,100 gives me 300. So I'm just solving the system of equations. Divide by 25 to find that p equals, what is 300 divided by 25? Is that 12, right? I think it's 12. 100 divided by 25 is 4 times 3. Yeah. Okay, so I have p. Now I'm going to remember, p is the number of pansies. So what this is telling me is she bought 12 pansies. Right? She bought 12 pansies. Now I need to find g. I'm going to go back to this equation right here, because it's the easiest one to plug into. So I have p plus g equals 14, but I know that p is 12. So I'm going to write 12 plus g equals 14. Substituting my 12 in for my p. Subtract 12 from both sides, and I find that g equals 2. G is the number of gladiolas. So my final answer here, she bought 12 pansies and 2 gladiolas. I spelled all these flowers right. And I'm done, because if you look back to the original problem, which I erased, it said the question at the end was, how many of each did she buy? Questions? I'm going to show you one other version, but it's not really harder.
Okay. Well, what's really the difference between this and...
Yeah, that's a good question. What's the difference between this and the problems we did before? So in the problems we did before, the question at the end is usually how much does each they're asking you for the cost. When you see that question, you set up your equations so that your variables represent the cost.
Oh, okay.
When you see the question that ended this one, how many did she buy, or does she have, or whatever? Let's say, did she buy? We set up our variables like this, the number of pansies. And the trick, the real key to these problems, is this equation right here. When we have the variable as the number of something, and we're told how much it costs. So P is the number of pansies, and they tell us each pansy costs 75 cents. We write that into the equation as 75p. Okay? 75p represents the pansy costs 75 cents. So if we take 75 and multiply it times the number of pansies, it will tell us the cost of all of the pansies. So this step right here is really the key step. Okay. Now, there's another type of problem that's just like this, but it's phrased a little differently. The way that we solve it is the same. So, Sarah has 25 cents in quarters and nickels. She has 17 coins. How many? And this is the key phrase, how many? And they're asking us how much, right? How many of each coin? Does she? So, this problem is the same. It doesn't necessarily look the same now, but the reason it's the same is because we know the value of a quarter, and we know the value of a nickel. How much is one quarter worth? 25 cents, right? And how much is one nickel worth?
10?
5 cents.
Oh,
5 cents. So, the first equation we're going to write is this one, the number of coins. So Q is going to represent our number of quarters. N is going to represent our number of nickels. And we're choosing that because they asked us how many. They asked us how much does something cost. Our variables equal the cost. They ask us how many. Our variables equal the number. Okay, it's kind of a trick. So then we know if Q is the number of quarters and N is the number of nickels, she has a total of 17 coins. So Q plus N has to equal 17. Now we need to use this information because we can't solve one equation with two variables. There's no way to solve that, right? We could have 16 quarters and 1 nickel, or 15 quarters and 2 nickels, or 14 quarters and 3 nickels. There's a ton of solutions to this equation. So we have to have another equation in order to really know how many she has. So our second equation, we're going to use the money. We're going to use the amount of dollars or cents that she has. We're going to set up this equation just like we set up the flowers one. The number of quarters times 25, that's the value of all her quarters. Plus the number of nickels times 5, that's the value of all her nickels. This has to equal what? Has to equal the total amount of money she has. 225. 225, like that, right? Should be going, whoa, whoa, wait a second. How much is a quarter worth?
25
25 what?
cents.
Cents. How much is a nickel worth?
5
Five.
5 what?
cents.
Nickels. Cents.
How much does she have?
Two.
225. 225 what?
Dollars.
Do-
Wait,
dollars.
Yeah, dollars. Yeah.
But these are cents.
Right.
So, we need to have this one in cents. So it's 225 cents. Right? Okay, now I need to solve these. There's many ways to solve this system of equations. I like, for me, the way that I would solve this, I think, is I would multiply the top equation times -5. And the reason I'm going to do that is I'm going to rewrite this equation up here. 25q plus 5n equals 225. And then the second equation is going to be -5q minus 5n equals -17 times 5, so 85, I think. Is that right? I think so. So the reason that I chose to make this one negative, all my smaller numbers are negative. So when I do 25q minus 5, I'm going to end up with a positive there. It doesn't really matter. You could make either one negative. You also could have multiplied this by 25 to make the q's drop out. It doesn't really matter. I'm going to add my two equations together. 25q minus 5q gives me 20q. 5n minus 5n, that cancels out, which is what we wanted to happen. 225 minus 85, I believe, is 140. Is that correct?
Yeah.
And then it's gonna go in
Think so.
7 times.
We're going to divide both sides by 20, and like Lucas said,
9.
it's going to go in 7 times.
Are you sure? Wait. Oh, because they're going by 20. So okay.
So we have 7, that's our number of quarters. So we have 7 quarters. To find the number of nickels, again, I would go back to this really simple equation. And I'm going to plug my q into this equation. So I know that 7 plus n equals 17. Because 7 is q. Subtract 7 from both sides. N equals. So I would say she has 10 nickels and 7